Hello, everyone, and thank you for joining us for the second session of Empire Academy. This is a monthly interactive series where AWS solution architects provide in-depth and hands-on knowledge on AI, ML, and analytics services. My name is Eshna Agarwal, and I will be your host for today's session. We will be focusing on integrating MLOps using AWS services for today's session, which will be conducted by Julian Bright. He is an AI specialist, solutions architect with AWS. Julian is an experienced technical leader with strong analytic skills and experience across a broad range of disciplines, including data science, architecture, software engineering, statistics, and applied machine learning. Prior to AWS, Julian co-founded two ventures and has worked with Microsoft, the BBC, and Fairfax Media, among others. Through this session, you will receive an overview of MLOps, its features and benefits, and the new features in Amazon SageMaker that enable MLOps. You will also get an overview of the relevant orchestration frameworks and tools, an MLOps demo, and understand the various data integration options possible with AWS services. With that, let's begin our session.
My name is Julian Bright. I'm an AI specialist solution architect, and today I'm going to be talking to you about DevOps for data science, operationalizing machine learning. Today I'll cover what is DevOps for data science, or MLOps, what's new in Amazon SageMaker for MLOps, some orchestration frameworks and tools. I'll run you through an MLOps demo, and then we'll touch on some data integration options before I wrap up. So, what is MLOps? Well, MLOps, just like DevOps, is part of the Agile Manifesto. And in terms of the principles, this is one of the things that I think is really relevant. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software, or in the case of machine learning, that's valuable insights from data. So how does that differ from traditional DevOps? Well, if we look at the software development lifecycle, what we see are steps from building source through to testing that source code, deploying that source code, and then monitoring that source code. And this is typically done through a continuous delivery pipeline, which is often completed in a matter of minutes. Now, machine learning deployments are quite different in nature. In a recent survey, Algorithma found that 55% of companies have not developed a machine learning model at all to production. And so the ones that have completed that production deployment, few have done so in less than a week, in fact, less than 15%. If we look at the 1 week to 3 months time period, 50% of companies are able to deploy a model in this time frame. And the remainder are over 3 months and in some cases over a year. So we're seeing a big discrepancy here from that very fast early release cycle from software development compared to machine learning. So why is this? Well, machine learning has an interesting challenge whereby code and data are independent from each other. So in the training process where we build a model, the code is independent from the data and the model is an artifact of this training process. So the code defines the algorithm, the architecture of that algorithm. For example, it may be a deep learning model with a certain number of layers, or potentially a gradient tree boosting model with a certain number of trees or depth trees. The configuration for that model, including various parameters that we'll use to train the model. And then in terms of the data, we need to make sure we have good data validation strategies, including being able to shuffle this data and split it into training sets, validation sets, and test sets, to ensure that our machine learning algorithm is learning. And finally, to feed the data into the model, we often need to perform some transformation or feature engineering to make this happen. So for the model artifact, we then need to perform analysis on this. So we look at those predictions, we look at the metrics that we're capturing, we compare those to what we expect from the labeled data. And then in terms of that model, there's usually a tuning exercise to try and improve the outcomes of that model, potentially try different types of architecture or algorithm. And then, of course, the deployment once we're happy with that model. So here's a few challenges that we see with machine learning. Really, the first one and most important is that the ML code is only a small part of the solution, as depicted here from 2015 paper published by Google, talking about the hidden technical debt in machine learning systems. So what we see identified are a number of different systems that sit around the machine learning process that require engineering effort and processes to be in place for this to be an efficient process. In terms of the team structure, we often find different teams might own different parts of the machine learning process. In particular, data engineers are responsible for taking data from their various different data sources, ensuring it's clean and ready for ingestion, ensuring there's sufficient labels, such that data scientists can then build predictive models over these data sets. This process is iterative and will require a lot of time for data scientists to experiment before ultimately deciding on pushing a model into production. Once that model is ready for deployment, often a team of software engineers or machine learning engineers will take those artifacts or assets and create some sort of deployment pipeline or process whereby the model can be consumed either as a real-time endpoint or through batch processes from downstream applications. Ensuring test quality is also a significant challenge. Automated tests can help with this process and improve the overall quality of the machine learning model. Things like looking at the data distribution, measuring that over time, looking at those metrics, the quality metrics that we're capturing both for the training process, and then also looking at feedback from the end users. In terms of detecting high-level insights, such as the exploratory tests required or the end-to-end test required, often requires humans in the loop as well. And these include things like validating for bias and fairness. So ensuring that the data set is distributed such that we've got a good representative sample across the corpus. Another challenge is detecting model drift and knowing when to retrain our models so that we can ensure that the quality of the models stay as high as we can. So drift can happen whereby schema or distribution of incoming data changes over time, or indeed the labels that we're looking to predict change over time. So those responses and the predictions and the inputs need to be measured so that we can detect this distributional drift. A static model will often, as you can see, degrade in quality over time. And so often a process of refreshing those models is necessary to ensure that these models are still performing accurately. So a process to detect this drift and then automate retraining is a good idea to ensure the lifetime of the model. So if we talk about MLOps as key challenge, and then we overlay these roles that we saw in the earlier slide, let's talk about three key challenges. And those are for model reproducibility, model auditability and explainability, model deployment and monitoring. And so from a data science perspective, we talk about sharing and collaboration being important for reproducibility. So that's where things like Jupyter Notebooks come into it. From auditability and explainability, we need good tools to look at that model analysis and evaluation. And then as discussed around drift, having that post-deployment in place is important so that we know what's happening with the quality of those predictions over time. From a data engineer point of view, machine learning pipelines or having predictable ways of taking input data and feeding it into the model and then having that artifact be deployed is quite key. And having those code and data artifacts with some lineage or integrity around them is also a key concern. And finally, from the deployment standpoint, ensuring the capability is there to be able to scale up and out as required for handling the load for these models. From a DevOps standpoint, being able to visualize and see what's happening with these pipelines, being able to understand from an experiment management point of view, are we improving those models? Are we ensuring that we have the right mix of models in play? Being able to capture training logs and prediction logs throughout that process is really key. And then, of course, in terms of that deployment, having that automated, having that continuous, and having the ability to roll back and when things are detected to be not as what we would expect for the model. So let's talk about what's new in Amazon SageMaker to enable some of these challenges to be improved from the end user perspective. So AWS has a very wide and broad and deep machine learning capability. In addition to our high-level AI services for developers, we're going to focus in on the machine learning services today, and in particular, some new capabilities in SageMaker, which is the Amazon SageMaker machine learning platform solution. Amazon SageMaker Experiments is the ability to track, organize, and compare training experiments over time. In particular, we can capture metrics, we can visualize these metrics, and we can attach these for various trials against an experiment. In terms of Amazon SageMaker Debugger, this is a new capability to perform analysis and debugging of models in real time as they're training. We can detect errors throughout the process to ensure things like overfitting or underfitting are not happening, and that by the end of our training job, we should have a good confidence that the model output is going to be usable for the next stage of the pipeline. Amazon SageMaker Model Monitor is something that we run once the model is in production. In particular, we capture a baseline measurement around what metrics of the data that we're sending in as well as out, and then to be able to compare the data captured from inference endpoints to be able to understand if there's actually drift detecting in this process and whether or not we would like to kick off a retraining job. So let's talk about orchestration frameworks and tools. Amazon SageMaker provides some native integrations for a number of orchestration frameworks. Amazon SageMaker operators for Apache Airflow and Kubernetes. AWS development tools such as AWS Code Pipeline, Code Build, Code Deploy, and CloudFormation can be integrated with the Amazon SageMaker suite. Amazon Step Functions or AWS Step Functions provide a nice way of building up workflows, and in particular, the Data Science SDK release makes this a lot easier. And then I'll touch on a couple of third-party open source solutions as well. So Amazon SageMaker operators for Apache Airflow allow you to orchestrate training, tuning, deployment, or batch transform processes through simple integrated operators that can be used as part of your data and ETL pipelines. The SageMaker operators for Kubernetes provide similar capabilities, but within the Kubernetes ecosystem. So for example, if you're working in the Kubernetes environment to perform some data transformation, and then you're wanting to kick off a large training job or potentially tuning operation, which requires spinning up multiple different nodes, you can use SageMaker, which will outsource this workload to the Amazon SageMaker managed cluster for this process, and then return back to the Kubernetes cluster to complete the rest of that workflow. From the Amazon AWS development tools perspective, we provide a number of tools to support that continuous integration, in particular automating kicking off a new build and test the code in a consistent, repeatable fashion, continually have artifacts ready for each of those stages of the pipeline, and close that feedback loop when a build fails. Code Pipeline is a tool to support this continuous delivery. There's a visual interface within the console. You can integrate existing or third-party tools, and in particular, we're going to showcase the AWS Code Build and CloudFormation integration. For continuous deployment, what you're looking at is being able to deploy new changes to environments for testing initially, and then deploy those safely to production without impacting customers. So the value proposition here is faster, frequent delivery to reduce the time to take those machine learning models into production environment. AWS Code Deploy, in particular with support for Lambda, allows us to create Lambda API endpoints in front of SageMaker endpoints, and then use a blue-green deployment or canary deployment approach to gradually transfer traffic from the old endpoint to the new endpoint and detect any failures with rollback, automatically rolling back to that previous version. And when leveraging CloudFormation with Code Deploy, we can have a layered approach, so layering application IAM creation, VPC creation, metrics around monitoring, and then of course there's resources and Lambda functions all the way up the stack. And CloudFormation can be used to support multiple isolated development environments for testing as well as that production environment. And best practice is to use smaller files, as these are easier to write and test and troubleshoot. AWS Step Functions Data Science SDK provides a similar capability to Airflow insofar as we can kick off training jobs, tuning jobs, deploying those model artifacts to real-time endpoints, or provide batch transform processes. And with these direct service integrations, such as SageMaker, we can avoid having to write polling type infrastructure similar to what you see here, where we have to submit a job, wait a period of time, get the status, check if that's complete, and then repeat this loop with a simple direct integration such that when we trigger this job, the next step in the pipeline will either be a success or failure condition based on the outcome of that step. So greatly reducing the code required for the step function. In terms of third-party open source integrations, MLflow is an open platform for machine learning. It provides integration for things like S3 to store artifacts for machine learning jobs, SageMaker to actually train the jobs, and as well as metadata stored in RDS or other SQL stores. Netflix recently announced Metaflow, which is a framework for building and managing real-time data science workflows with ease. And in particular, the Python code that you can see here allows you to create a directed graph for various steps and offload some of these steps to high-level functions such as batch processing in AWS, or in the future, SageMaker and step function execution. Great. So now we're at the point where we're going to talk about MLOps demo. But before we do jump into the actual console, let me talk you through the process of what this demo entails. So the use case here is bank transaction classification. As you can see on the right there, we're looking to classify monthly expenditure against a number of different categories. And we're going to use a machine learning model to predict these categories. And this helps provide insights on spending and understand how you can improve your spending patterns. We're going to use an automatic model retraining process to take new label data through this process and improve this model over time. So let's look at the architecture for this solution. We start with unlabeled transaction data, which includes the statement text, an amount, and a date. We then use Ground Truth. Amazon Ground Truth is an annotation tool to allow humans in the loop to look at these statements and to be able to provide the category for us so that we can then build a labeled data set and train a model. So that labeled transaction data is an output of that process, which we can then feed into the Amazon SageMaker training job. Once we have our transaction categorization model, we can deploy an endpoint, put an API gateway in front of that, and then start consuming that from our end user application. Those requests and predictions are being logged to S3 as part of this invocation of the endpoint. And any results that are not of sufficient quality, potentially a low probability, can be fed back into the labeling process through Amazon's augmented AI, which is powered by the Ground Truth annotation engine, and repeating that cycle. In terms of producing a monitoring schedule, the first step in that is to create a baseline job, and this will produce statistics and constraints on that transactional data. We can then schedule a monitoring job, which will compare those new predictions that we captured against the baseline data and produce some results for statistics and any violations against the baseline. Those metrics can be published to Amazon CloudWatch, and we can set up alarms to detect drift or anything that may result in a retraining process. And so a Lambda can be used to restart this process and begin another training job. So we're going to use the AWS development tools, in particular CodePipeline, as the orchestration layer for this process. So we've got a number of high-level steps in this pipeline. As you'll see, the source step, which ingests Git source, the container, custom container, as well as the data source, builds those artifacts, kicks off a training job. The deployment step has an approval gate before we push that into production, and then we monitor those outputs. So what does that look like from a continuous integration and deployment point of view? We start with our sources, as we mentioned. We have that build step where we use AWS code build to push those artifacts to S3. The training process will then run a CloudFormation step, a CloudFormation job as part of those artifacts, which will ultimately land a training job in Amazon SageMaker. The deployment will then also use CloudFormation to create a SageMaker endpoint. And then we'll have a manual review step where we use a Jupyter Notebook to inspect the validation test against this endpoint. So in a sense, validating that the new endpoint that we've deployed is actually providing the results that we would expect. Once we're happy to productionize this model, we can then go through another workflow that uses the code deploy process to perform a blue-green deployment. And then finally, we monitor that process so that we can retrain as required. The code build specification I'm showing you here is what is used to kick off that initial build artifact step. So in particular, we reference an environment that we're looking to use, so Python. We install some libraries here. This is a simple YAML file. We run the Python script that is going to create our artifacts, in this case, some CloudFormation templates. And we can use the package command from CloudFormation, which will upload to S3 the necessary files that we need to create our API Lambda functions. And those assets can be included so that when the next step of the pipeline runs, they can access those assets. To give you a bit of an insight into what the CloudFormation production step is doing, this is extending that development CloudFormation step with a blue-green deployment and monitoring actions. So you can see here in the orange box, we have a monitoring step, which will enable data capture on our endpoint. This will be necessary for performing a monitoring schedule as to compare against the baseline which we captured previously. The code deploy step will initially send some traffic to that endpoint that we spun up, enable some alarms such that any traffic that is sent to that new endpoint that causes an error will result in the code deploy to roll back. Assuming there are no errors, the post-deployment step will complete, and then we'll have our API endpoint pointing to our new resource. And auto-scaling is also enabled for the endpoint as part of this process. The nice thing about this is it's a fully immutable process whereby any of these steps were to fail, this would roll back and no one would be the wiser. And that's because we're using AWS Code Deploy's blue-green Lambda deployment, which will have a process where it shifts traffic gradually from an original endpoint to the replacement endpoint. And it can do this over a period of minutes or hours even. And you can decide whether you want to use a canary process, which is essentially to send only 10% of the traffic for the whole time and keep 90% to the original endpoint, or you can linearly send that traffic over a period of time until you reach that 100%. Because we're using CloudFormation to perform all these steps within a resource, we need custom resource for certain actions. For example, triggering a baseline training job and setting up a scheduling job. These are not native CloudFormation capabilities, so we can simply create these with the help of the custom resource helper or Python library. And as you can see, all you need to do is annotate some Python functions and perform the relevant create, update, or delete code. And in terms of those endpoint data capture, here is a sample of what you can expect to see both in the input capture and the output capture. So the input, we're capturing the statement text, the price, etc. And then the output is the predicted label along with those probabilities for each of the labels. And in terms of monitoring, what we'll demonstrate as part of this demo later is the ability to compare any drift or completeness against that baseline. In particular, what we'll see here is there's a class prediction drift whereby the classifications or categories that we're seeing in the real-time prediction endpoint don't quite align with what we're seeing in the training set. And this could be indication that we've got some new data coming through that's going to require retraining off those new labeled data. And finally, as part of this process, we want to ensure that we've got the relevant CloudWatt metrics and alarms in place, in particular for the blue-green deployment, so that we can roll back as required, as well as to detect drift and take an action to retrain off the back of this. Great. So that's a summary of the demo. Let's jump in to the console and see how this all hangs together. Okay, here we are in the demo. So this is the MLOps demo. This is a Jupyter Notebook running within SageMaker. So I'm going to just install some libraries here. And the first thing I'm going to do is start a build in this environment. So I'm going to pull in some variables. I'm going to create a JSON file and I'm going to zip that up. I'm going to upload that to an S3 bucket. So this is the response from that S3 put. You can see there's a version here. Now, if we jump into the code pipeline, we should be able to see that we've just now kicked off a build. So that source has executed with the new data source that we've uploaded. That will then transition into the build stage. So you can see that's now in progress. So if we have a look at what's happening in here, we can see there's two steps. There's a code build template step and a CloudFormation step. The code build step is in progress. We can view this. So this is one of the managed services within the development tools. In here, we'll be able to see the status of this, which is actually just completed. And so this has executed a Docker file here where a number of steps have been taken, ultimately producing some assets that are then artifacts of this build. And so if we look at the build details here, we'll be able to see that there is in fact an artifact attached. So the next step in the pipeline is to create some custom resources. And so if we look in CloudFormation, what's happening here, we can see that a number of events have been created to enable custom resources to be executed within the code pipeline. So that's now completed, and now we're on to our training step here. So there's a couple of steps in this exercise within training. The first one is to create an experiment and trial. And we're doing this with a Lambda. As you can see, that succeeded successfully. And then the next two steps in parallel are training the model and also creating a baseline on that training data. So these two are now in progress together. These are both CloudFormation steps. If we have a look at the training step, we'll notice that there's a number of actions to be taken here, such as creating a training job. And then off the back of that training job, there will be a step to validate that training job has completed. So if I go into SageMaker here now, and we have a look at training jobs, we'll be able to see we've got an in-progress training job here. Now I'm going to pause the video here for a minute until these jobs will complete. Okay, so our training job is just completed, and so is our baseline job. And so onto the next stage we move, and we get a endpoint deployment. Now, if we go to our demo here, we can move on to this stage here, and we can test an endpoint. So the first thing we need to do is get the execution ID of the current pipeline. We're going to download a data set here for testing against this deployed pipeline. So if we look at that, we can see there's a class or a category, eating out, transport, health, etc., and some text associated with this as well as an amount. So this is a typical statement information that is available on a bank or credit card statement. So let's just have a quick look at those amounts against classes and see what that distribution looks like. So you can see here there's quite a few eating out expenses. Most of them are small. And then there's a smattering of other expenses, groceries, transport, travel, etc. So here we're going to make a call to that endpoint. using a payload that we've downloaded from that test data set. And we're going to load that back to capture the prediction and the probability. So here you can see we're doing a pretty good job of matching those two up, with one mismatch here in that example. Now we can measure the accuracy over all of this data set of 100 sample records, 86%. And if we want to look at a confusion matrix, which essentially plots each category against each other, you can see we're getting a high correlation here for our true positive eating out. And then along the diagonal, which is the true positives, where we're getting some good hits. And if we want to break that down into a table, we can use that same data to show the true and false positive rate here for each of these. Okay, so the next step in the pipeline is an approval workflow. So we're using a Jupyter Notebook widget here. Okay, and we're going to put a comment there to approve the deployment, please. So if we go back to the code pipeline, we'll see that that approval step has just completed. Now we'll wait here until the prod deployment is complete and have a look at that stack. To know that it's complete, we can inspect some events here. So this is essentially a table of events that we get if we were to look at that CloudWatch or CloudFormation rather stack. So if we click through to here, we'll see those same events appearing here. So what we're looking for is essentially endpoints to be deployed. So we're going to go have a look at endpoints. And you can see here we're creating an endpoint that's a production endpoint as well as a dev element point. So we've got two steps in the pipeline running right now. This has got a number of steps to do. So we'll just pause the video here while we wait for some of these steps to complete. Okay, let's see where we're up to with this status. Right, so we've moved on from the endpoint capture. We've now started that deployment. So let's have a look at that. Let's send some traffic to that test endpoint again, and then let's see if we have a REST API available to us. Looks like we do. So we should be able to start sending some traffic to that endpoint. If we go to SageMaker, what we'll notice is that we've got two endpoints in service that are production endpoints. So we've got one production endpoint that starts with 4DC, one that starts with ECO. And if we go to our code deploy application, what we'll notice here is we've got an in progress deployment. If we click through that deployment, we'll see a particular item in progress here. So what we're seeing is a deployment, pre-deployment step successful. We're seeing a traffic shifting step here, and we're yet to see that post-deployment. Now, these two functions are lambdas that can be called with custom code. So in the pre-deployment step, I'm doing an endpoint check. And in the post-deployment step, I'm running a check to see that I've received logs. Now, if we go back to our code here, we should be able to see that we've started to cut over to that new target. Okay, so now we've had that complete. We're moving on to look at some monitoring information. So the first thing we're going to do is look at the baseline. So you may remember in the code pipeline, we had here a step that ran in parallel with training, which was suggest baseline. And then once we had the production deployment, as part of that, we set up a schedule. to compare against the baseline. So let's execute this. We've got a processing job for that baseline, and we've got a schedule name here. We're going to go and load the results for that baseline. And we're going to look at the generated constraints, which are these ones here. I'm just showing a sample of this table here, but essentially you can see that for the string predictions, there's no constraints other than the number present and the distribution of those values. For fractional probabilities, you've got number present as well as some distribution values here, in this, as well as the minimum values, etc. And in terms of the constraints or suggested constraints, you can say the suggested values for the class predictions, as well as whether or not these are non-negative. So the scheduling works by reading data capture values from S3. And I'm going to load up a value of one of those files. So we found 67 files. The last file is a input of this, is some text, and an output of eating out. So, this is a highest probability column, so it's matched to that. In terms of the schedule, what we can do is download that schedule. We identify that it completed with violations. And then we can have a look at those results. So the schedule provides 3 files: a constraints, statistics, and any violations that happen against the baseline. And we can actually visualize that here in this table, which shows us for a number of those columns, the fractional columns, how complete they are. So we're missing some data that we perceived on the training set around education fees, etc. And we're also missing some of those class predictions. And importantly here, we're seeing a drift. And that's a good indication that we haven't got enough data coming through that reflects a training set, and it's potentially worth kicking off a new training job. Now, if we go and have a look at the CloudWatch metrics around this, let's refresh that screen. What we'll see here is initially on the top, some Lambda invocation metrics. So here is essentially the number of count methods for those total invocations, API functions, as well as the pre and post traffic, the latency for those events. And so you'll see there's a bit of a spike in latency here around 500 milliseconds when we initially deployed that and tested that endpoint. But we're not seeing any errors. Correspondingly, here you can see the latency that's going along with SageMaker here. Now you'll see a pretty predictable latency here, but what's interesting is that you'll see the actual endpoint itself change. And so this is because we had a deployment, and one endpoint is then replaced with another endpoint. And again, same here. We can see CPU and memory utilization as well between those 2 deployments. And the good news from alarms perspective is we didn't have any alarms as part of code deploy, but there is this outlier here. And so that 0.482 actually correlates with the 0.482 here that we see in the drift. And so to complete this picture, essentially what you need to then do is assign an alarm that is able to be triggered to retrain the pipeline. And so essentially what that would look like is uploading a new data set like we did in the beginning that would then effectively release a change and then kick off this pipeline again. And so that would repeat that process of retraining, creating a new template here, etc. All right, let's recap. So we started with our source, container, and data. We built those artifacts, which push to S3, that would then trigger CloudFormation deployments to create a training job, CloudFormation deployments to deploy that endpoint for a dev environment. We had an approval step, which then resulted in the production deployment through code deploy and API gateway lambdas being set up. And finally, we had some monitoring that we looked at CloudWatch, and then we saw how we could trigger a Lambda to retrain this process. So what about AWS step functions? Well, here's an example of AWS step function workflow. It's quite similar insofar as you can create a training step, deploy an endpoint, and create that endpoint. These steps are all sequential, and they can be set up simply through the use of some Python code and the AWS Data Science SDK. Here's an example of creating a training step where you pass in the estimator code, some data inputs, then you chain these steps together to ultimately deploy that real-time endpoint. You can either update an existing workflow like seen here or create a new one. And then you can execute that workflow by passing in these input parameters, or you can use a CloudFormation template to do the same thing. So let's compare these orchestration approaches when considering managed deployment with code pipeline, CloudFormation, or step functions. So for continuous integration, code pipeline can automatically detect source changes for you. With the step functions, there's support for an integrated polling of these services, so you don't have to do that yourself. However, you still need to think about how you're going to trigger these step functions, and that could be a CloudWatch event or potentially Event Bridge. The code pipeline provides nice support for staging actions. In particular, each stage will be blocked while they're executing, and any stage or any source that is updated will be superseded on a previous stage. In terms of step functions, executions are run independently, and so if you wanted to include some sort of staging, you'd need to think about state management. The flow of a code pipeline allows a single pass through the pipeline with support for parallel actions as we saw. Step functions are a lot more flexible because you can design loops, conditional logic, retries, etc. And in terms of change control, when leveraging CloudFormation with code pipeline in particular, there's great support for automatic rollbacks, and having those approval steps mean that you can have gates so that you can have a human in the loop reviewing these processes before moving forward. So with step functions, you need to build in some compensating actions to be able to roll back any steps, as well as handle errors that were produced as part of this process. So in terms of data integration options, data lineage and provenance is really key for model reproducibility. So it's important to think about how you store data and feed this into your model pipeline. Versioning data in S3 is a very common approach that we see with customers. And also using Apache Spark or Glue to land the data in S3 for large data in particular is common practice. If you have open source software such as Hoodie or data version control, which is a Git-like tool, and in Kubernetes, there's a software called Pachyderm, which can potentially help with triggering some of these data integration pipelines. Great. So just to summarize, I'd like to reinforce the fact that MLOps, DevOps for data science, is really a culture and technology working together. By using automation, you increase your deployment velocity, reduce costs, and help bridge the gap between some of those different roles in the team. By leveraging managed orchestration, you can have seamless pipelines that will automatically trigger and be very low effort to manage. By adding monitoring and alerting on different development life cycles, you can do things like retrain on drift detection or take other actions. Thanks very much for listening. Hope you learned something today, and good luck on your ML journey. Please give me feedback to let me know if this was useful and helped you on your journey.
With that, we come to the end of the knowledge sharing part of the session. I'm sure you all must have a lot of questions. To help answer them, we have with us Praveen Jaikumar, Principal AI ML Solutions Architect with AWS. Praveen has more than 23 years of industry experience in design, development, and consulting across multiple business verticals like banking, financial services, and media and retail. An alumnus of BITS Pilani, prior to AWS, Praveen has also stints at Cognizant, Vmox Technologies, and SRA Systems. Welcome, Praveen.
Thanks, Ishna. There are a few questions that is already there. So let me kind of go over that. And yeah, please keep sending the questions. So the first question is from Nidish Chetty. So the question is that what are some of the common errors to avoid while integrating ML ops using these services? So these, I mean, this is typical to your CI/CD, right? So some of the things which you want to avoid when you are using continuous deployment, make sure that there is a proper process. I mean, so you're going to deploy it automatically, right? Basically, so, but yeah, just have a proper conditions around it. Just that there is an approval process for you, somebody to go and deploy it. So that's the first step. Have a human in the loop, right? Some of the functions that you see allow you to do that, and also have some value. If you're going to do it automatically, just make sure that you have some proper validation condition, right? So in the machine learning world, you make sure that the accuracy is at a certain level, basically, right? So that would be one of the things. Or you might want to see some other metric which you are using crosses the threshold, right? So these are some of the things which you would typically set it up just to make sure that you are doing it in the right way. Right? So I'll go to the next question. Next question is from Karthik. So the question is on, are the services mentioned in today's video compatible with my current AI/ML stack? Would it be better to integrate the service or replace my current AI/ML stack with them? Right. So Karthik, I'm not sure which AI/ML stack are you using. But having said that, you should be able to almost any of the either let's say if you're using statistical algorithms like let's say XGBoost or scikit-learn framework, or let's say if you're using framework like a TensorFlow, PyTorch, or MXNet, you should be able to integrate this with the current set of stack that is available. Julian kind of covered our CI/CD stack, which is like agnostic to any framework, right? So you could bring in your any model basically, and I mean any framework you have, and you could start using it, right? So that's the first point. And the second point over here is that typically in so what we provide, let's say with step functions, with the data science SDK, with Julian covered. So what we provide is a set of typically what happens in machine learning, right? So you get the data, you train the data, you do the hyperparameter tuning of your data, you evaluate the data, and then finally you deploy your model, basically, right? So these steps can be you take any machine learning process, these are the steps involved. So you could code that using that. I mean, you could use either the CI/CD stack or the step function, which Julian kind of spoke about, right? Apart from that, we very recently also launched something called SageMaker pipelines. So SageMaker pipelines is to an extent similar to the step functions and the data science SDK, but the only difference is that you will be able to do all of this SageMaker, I mean, the creating the pipeline and create an entire pipeline in a single UI. Basically, you get into SageMaker Studio, and you will be able to execute end-to-end, create right from your data gathering till you do your inference, you would be able to do it, right? So SageMaker pipelines is also another option. Just to conclude, I mean, to answer your question, yes, it can be used for any AML stack. It should be possible to do it. Right? So let me go to the third question. So this is basically on how to understand and interpret the metrics for AWS personalized solution version. So this is not directly related to MLOps, but so with the personalized, right? I mean, so basically you kind of get 4 different metrics. So one is the coverage metrics, and then you get a mean reciprocal rank, and then you get a normalized, discounted, cumulative, and precision, basically, right? So these are all the 4 metrics you get. So the idea is that the higher should be the value, then the better your solution is, basically, right? So if you increase your, let's say if the coverage is closer to 1, then that means that it is capturing most of the recommendation that it needs to capture in your test data, right? Something similar to precision as well. So the idea is that with all of these 4 metrics, just make sure that your value is closer to 1, basically, right? So that's on the personalized side. And with the new recipe that is coming, that is there for, I mean, probably around for 3-4 months now, user personalization is a recipe. So that brings in a lot of new capability into it. You don't need to worry about creating, let's say, if you have like the cold start previously, you need to create a separate solutions for it. Now, with one user personalization recipe, you will be able to handle most of your use cases. So I'll request you guys to try that out. It gives you a lot of good features around that, right? So going on to the next question. Next question is from Jayati Jain. So the question is, what's the scale the system can handle in terms of amount of data that can be processed at the same time, right? And there is another question as well. So I'll first take that first question, and then we will go to the next one. So the scale of the system. So basically, I mean, what we showed you is that just the CI/CD part of it, right? So one of the steps inside the CI/CD is your data processing, right? So you want to process large amount of data. So let's say if you're using SageMaker processing for the job, right? Or you could also use something like one of your Spark job to do your processing, right? So that is given, that is open to you, how you want to do your processing, right? If you take SageMaker processing, yes, you can handle GBs of data, terabytes of data. We provide a way to distribute your data across different instances and run it as well. So if you're using SageMaker processing, you can distribute it and run it. And obviously, let's say if you're using a Spark kind of a job, basically, right? Spark inherently is made to handle huge amount of data. So that also can give you handling. So that also can handle large amount of data. So I don't think we would have a challenge in handling the data. So the only thing you need to be cognizant of the fact that how do you want to do a distributed data, basically, right? You want to distribute the data across multiple systems and run it so that you can reduce your time, kind of the horizontal scaling which we talk about, right? Probably that's the one thing which you might probably want to look. Is there an alerting? Is there any alerting is available for data distribution changes? Sorry, I'm not very sure what you mean by that, but I'll try to answer this question. I mean, is there any alerting is available for data distribution changes? Okay, not sure what was the question meant. If you could give me a little bit more context, then probably it will help. But having said that, I'll tell you, we within SageMaker, now we do provide different options to run your training using distributed data, basically, right? So we provide a framework. We provide both the data distribution and model distribution. That's the new feature that has got launched in the last 2 months. So let's say if you're using TensorFlow or a PyTorch, and you have a large amount of data and you want to do a distributed training, basically, right? To reduce the training time, we do provide a framework that can help you to do it. You can compare. If you take TensorFlow provides you something called Harvard mechanism, right? This came out of Uber kind of donated to the Harvard, right? So something similar, we provide a framework which can help you to do the distributed training, basically, right? And we take it one step further as well. It's just not data distribution. These days, we see that there are some of the models tends to be very huge. When I say models tends to be huge, I mean that the network size is very large. So you cannot fit in let's say one GPU or one GPU instance machine, right? So you might want to break the model itself into multiple instances and then run the training on, right? So probably you will be running your first in the network, the first 10 part of the network, you will run it in one instance, the next 10 in another set of instances, right? So that is absolutely possible using SageMaker. SageMaker provides a way. It will determine how many layers needs to run in one instance, how many layers needs to run in another instance, and it can help you to do that as well. So that's the support which we have in distribution. But I'm not sure if I answered your specific question because I didn't understand when you meant data distribution changes. Yeah, we support distribution in different formats actually. Right. So the next question is from Tamil Maran. So what would be some of the skill sets ideal for a person to supervise and maintain MLOps practice? So the best skill set predominantly is, I mean, you need to understand the CI/CD process to an extent. Definitely, that is important. So how does a typical DevOps process? I mean, if you have experiences from your application development side, right, a lot of it is still applicable. As Julian was mentioning that, yeah, it's different in the sense that now in a typical CI/CD, your data is not involved, only the code part of is involved, right? Whereas here you also have a data, but the concepts are still similar, right? So how do you want to do a blue-green deployment? How do you want to have a A/B testing module? All of those concepts are exactly similar. So the first set of requirement you need to have is that to understand the CI/CD process or the DevOps that is there. And definitely for ML ops, you need to understand how typically an ML process that happens, right? Right from where you are getting the label data, how does the feature engineering happens, what are the steps that is involved. I mean, you don't need to be a data scientist to do ML ops, but still you need to understand how the feature engineering is being done, and then how the training happens. Then if there is an hyperparameter optimization step, how it is done. Definitely you need to understand how they are calculating the evaluation metric for a certain algorithms, and then finally the deployment aspect of it, right? So I would say that understanding the DevOps and then understanding the machine learning process is definitely a skill set somebody would need to be the ML ops person, basically, right? Uh, I'll go to the next question. So again, this is a question from anonymous attendee. In your experience, what are some of the best practices for maintaining ML ops? Right? That's a good question. Uh, as Julian kind of mentioned about two things basically, right? One is the CI/CD process of it, where he kind of showed your data being stored in code commit, which is a repository, and then from there triggering of your entire process basically, right? So either with basically using using the CI/CD set of tools like code deploy, code pipeline, which you show, which like Julian showed. Definitely, you could use. You can have your code inside code commit and then stick up all. Start all the process, right? So definitely, that is a good practice. You could also do the exactly same thing with step functions and also the SageMaker pipeline feature, which we have. So as much as possible, try to decouple things, right? Basically, I mean, like in the code which Julian was showing, the data gathering is one step, and then the feature engineering part is one step, and then training, evaluation, and then deployment, right? So if you could actually break down your process and then have an automated way of running it, so that will be the first step, first best practice, right? And again, another very, very important thing, which Julian also covered, is on data drift, right? So probably it is easier to get your first model into production very fast, but in our experience, what we have found is that all of this model starts having this model drift or data drift at some point of time, right? Because your business is not going to be same as like what you did about when you developed your model. So have a way to capture the data drift, right? Within AWS environment, SageMaker monitoring provides a way to capture this data drift, which was shown by Julian in his demo. So have a way to capture the data drift, and then you can make an informed decision for doing the retraining, right? So if you could set up an automation process, let's saying that, hey, when this particular feature has a data drift of about 20%, right? You could actually define that what is the threshold you want in the SageMaker monitoring, right? It will compare your training data statistics with the data that is coming in, the inference data that is coming in, and then it can do a comparison and it can tell you how much each of your feature is having a drift basically, right? And then now you could write a code that says that, hey, when there is a drift of more than 20%, then probably then that's a high time for me to do a retraining basically, right? So you need to set up this entire process so that you kind of avoid the model drift, and your model is going to give the very correct result as and when. That's the important thing. Right? At the end of the day, that's the business problem. There is a business problem, and you're trying to solve it using your model. So you want to make sure that your model is solving the business problem correctly. So make sure that there is a process to capture the data drift, and you could automate the entire training process is a very, very important thing. In fact, in one of the slides, Julian kind of took it to the next level where he said that integrate your the inference data that is coming in with the ground truth, so that there is a proper labeling process and there is a human that gets involved who can change if the labels are wrong, and then kind of redo the training as well again, right? So these are some of the best practices that we have seen customers using it in the field, right? There is the next anonymous, there is no name, it says anonymous attendee. What is the best way to store pre-processed data in machine learning pipeline, right? Again, a great question. So you want to store the pre-processed data, right? Again, it depends upon how you want to process the data, right? As I said, you could use SageMaker processing, or you could run it in a Spark environment. The data could be in a Spark. You could run your processing in a Spark environment and then use it for your training, right? So it really depends upon where you are getting the data from. I mean, definitely one of the recommendation is that, hey, have the data in an open format, right? So don't use any of the proprietary formats. So if you want to move across frameworks and other things, you might have a problem, right? So when I say open formats, things like Avro, Parquet, and other formats, right? So if you can get your source data from there in that format, yeah, well and good. You could use that. It can save your space as well, and a lot of benefits it brings within. But a lot of times that is not possible, right? Because you are going to get the data from a source system you don't have really control over. But at least once you process the data and after process the data, store it in one of these formats, right, in the open format. Most of the frameworks takes this data in one of these formats, right, either Parquet or Avro. If you're using tabular kind of a data, it will take it in that format. So the advice would be is to use the open format both for pre-processing and the process data. But I also do understand that there's a lot of cases where you don't have control over the data that is coming for pre-processing as well. So the next question is from Viba Chaudhary. Uh, for a new innovation thematic concept, can we have a test pilot method where our development team can gauge the software tool fitment and match? Okay, so let me try to read the question again. For thematic concept, can we have a test pilot method where our development team? See, I mean, okay. So basically, one way to try it out is that if you're very new to machine learning itself, within the Amazon Amazon environment, we have something called SageMaker. SageMaker has something called Autopilot, basically, right? So that could be a good start for your team. So what Autopilot does is that you need to provide the data to Autopilot. The data has to be in a tabular format. Let's say you're trying to do some classification or regression. Provide the data in that format. And then what SageMaker can do, SageMaker Autopilot can do is that it does, in data science, we call it as various feature engineering. It tries to do different types of feature engineering and also runs your data across different algorithms using this combination of feature engineering, right? And then finally, it kind of gives you like a leaderboard. It says that this particular algorithm with this feature engineering provided the best result for your data, actually, right? So, and this is unlike some of the tools, this is not a black box. This is completely a white box environment. We give you all the transformation, all the code, that the logic that we created, right, that we generated is made available to you. So let's say tomorrow, if you hire a data scientist, all your developers can look into it. And if they want to continue to make any modification, you could do it, right? That is from, let's say, if you have a data and you want to try it. Another option, Viba, we have is that we also provide a lot of API services that really doesn't require you to do a lot of heavy lifting, like that. I identify what's the algorithm and all those stuff, right? Let's say if you have use cases around image, basically, right? We have a service called recognition. All you have to do is that make a call to APIs and it will work. Or let's say if you want to convert call center call recordings to text and might want to do and you want to work on top of it, yes, we have a service called transcribe. All you have to do is just make some API calls, you will get it, right? You don't need to worry about training the model or anything like that, right? Again, another question which I answered early on is that on personalized, let's say if you want to do recommendation, I mean, you go to Amazon.com or Prime Video, you see recommendations, right? I mean, a lot of us, based on the recommendation, we click and go watch a movie, or in the shopping sense, we go buy a product, right? The same frameworks, the same algorithms that we use, we have provided you in in the personalized environment, right? All you need to do is that bring your data, we will run the data across these algorithms and then deploy the model for you. All you have to do is that call those APIs and get the result, basically, right? So it's just not you doing you doing your modeling by yourself. We also have quite a few AI services which can help you to do it, actually, right? So is there any courses for this at any LMS? Okay, so this is a question from Binay. So on the LMS, so I'm not sure if we have ML Ops specifically as a course, but what we have done is that we have opened up our internal repository, which contains multiple, right from the topic for a beginner to advanced users of machine learning and deep learning. We have opened up the course materials within Amazon. So if you could search for in our website, if you can go search for machine learning university course material from AWS, just try googling that. You'll be able to land up in a site where you could find out that has information right for beginners to the advanced users. But I'm not very sure if there's a lot of information covered on MLOps specifically, but generally on machine learning and deep learning, you will be able to find quite a lot of information over there. Right. So let me go to the next question. Again, it says anonymous attendee. Is is there a support for model ops for using auto ML? Okay, that's a good question, actually, right? See, as I said, when you are using auto ML, right? We within SageMaker, we call this as autopilot, basically, right? I think you're referring to that. So what autopilot kind of provides you is that it gives you, end of the day, it gives you a code, right? Once you give the data, it says that for your data, this is the best feature engineering code that is available, and this is the algorithm that we use. This is how we have done the training, and this is how we got the model out, right? So what you might want to do is that get those code. This is all notebooks that is made available to you, Jupyter notebook that is made available to you. Using that code, you could now build your ML pipeline, basically, right? ML ops pipeline. It's all you have to do is that you need to create multiple step functions. So your feature engineering would be one step function. Anyway, that code, you're going to get it from the autopilot. And then the training code is available. Probably you might end up, what you have to write is that you should write up your evaluation code, and then how do you want to deploy, basically, right? So I would say that even though you may not get the entire 100% of the code, 70 to 75% of the code that is available, all you have to do is write the orchestration around it, which I think should be pretty straightforward. I mean, I don't see a lot of complication in it. Yeah, you need to understand how the pipeline works, how the directed graph works, probably. But there are a lot of examples around. If you go to our SageMaker GitHub, public GitHub, you search for SageMaker pipeline, you would see that there are tons of examples available for you to get started, right? That could be a good place for you to get started. And then once you understand that, then start using your code. I mean, start using the models you have developed to put together for this pipeline, creating this pipeline. The next question is on why use AWS for machine learning. Okay, that's a brilliant question. So there are quite a few reasons why AWS for machine learning. So probably the first reason I would say is that our parent company, Amazon.com, has been working on machine learning for past 2 decades, right? So if you see the example I gave on recommendations, right? Amazon.com or Prime Video, you go recommendation, lot of machine learning and deep learning that is over there, right? We are trying to do drone delivery at some part, in some parts of the world, we are trying to do drone delivery. You take your Echo device, the Alexa device that you see, right? lot of NLU kind of work that is gone inside that basically, right? And another latest thing is that if you take in some probably some of you might know, in some part of the world, in US and Europe, we have started this stores called Go stores, right? So all you have to do is that you have your Go store app, Amazon Go store app. Walk into the store, tap it, walk into the store, you pick up whatever you want and just walk out, right? You don't need to face not even a single human in the whole process. You don't need to go pay your bill, scan or anything like that. We will pick it up, whatever let's say item, you just pick it up. We will, when you walk out, it automatically gets billed actually, right? So the point I'm trying to make here is that there's a lot of technology, deep learning, machine learning work that is being done within our parent company. And if you see what AWS is trying to do is that we are trying to bring some of those services to the customers over there, right? So purely from an experience perspective, we do have that breadth basically, right? And then the second part of is that if you take machine learning, it's all about data as well, right? I mean, there is once you have data, you need to have a way to run your machine learning in some of the latest and greatest machine, right? So we have high-end GPU machines, high-end CPU machines for you to do your machine learning trainings, right? So that's the second thing. And another interesting statistic is that if you want to take TensorFlow, right? TensorFlow, as all of you know, is from our is predominantly done by our competitor. But there are different studies that are being done. More than 80% of the TensorFlow workload runs on top of AWS, right? So what that means is that a lot of people prefer to use AWS. I mean, we have dedicated engineers who work on this third-party frameworks to make sure that they run in an optimized manner in AWS. So just to summarize, yes, I mean, our parent company has a lot of experience and we try to bring those experience to customer. We have some of the latest and greatest instances. I mean, if you want to call the hardware for you to do machine learning, and just not on that, we support for frameworks as well, right? Again, things like distributed, I talked about distributed model, distributed data. There are multiple features that is available to make your machine learning journey a lot more easier within AWS as well, right? So I think those are the reasons I would say why you have to come to AWS to use machine learning. Right? Okay, so there is another question. It's a pretty long question. Let me try to read. This is from Viba. We are very new in the market and creating only our Android or iOS apps and not a desktop web product yet for the same thematic innovative concept. When you're scaling up and want cross-device salience, best is to make basic minimum product and do actually native coding from scratch when we scale up, or we can reach out to AWS at current stage itself. While mobile code could be extrapolated, basically asking, is there any threshold number or criterion for app from our budgets? Viva, I think you could reach out to AWS at any given point of time, right? I mean, so from your AWS account, you could go into contact us. That will land into the right team based on your wherever you have created the account, right? It will land into the right team, and they can come and help you. Basically, I mean, I understand that you are trying to create an iOS, Android app. So then they can suggest you a best architecture for that, right? So yeah, so there are multiple, I mean, just reach out to us, and using the contact us page, it will get to the right set of people, and then they will be able to help you on how to go about doing this actually, right?
Thank you, Praveen. We have reached the end of today's session for the Empire Academy. We thank you all for attending and hope the insights you received today will unlock new levels of growth and efficiency. Stay tuned for more such power-backed sessions on AI/ML and analytics every month. Thank you and have a great weekend.